Good morning student. Previous class I discussed about the application of resonance effect. Next I discussed about the hyperconjugation effect. Next I discussed about the electromagnetic effect, and I also discussed about the bond fission. Now I am going to discuss about the components of organic reaction. Suppose take an organic reaction CH3 CH2 Beer plus aqueous KOH gives CH3 CH2 OH plus KBr. In this reaction there are generally three components are present. Number one is your substrate, number two is your attacking reagent, number three is experimental condition. In the organic reaction, the major component is called substrate. On the other hand, in the organic reaction, the minor component is called attacking reagent. In an organic reaction, experimental condition means generally we think about the temperature, pressure, catalyst like this. In this reaction, ethyl bromide is the major component, so it is said to be substrate. In this reaction, aqueous KOH is the minor component, so it is said to be attacking reagent. Next, I will discuss about the attacking reagent. There are general three types of attacking reagent. Number one is your free radical. Number two is nucleophile. Number three is electrophile. At first, I will discuss about the free radical. What is a free radical? The odd electron neutral species which are formed by the homolysis fission of a covalent bond is called free radical. Generally, the free radicals are formed by the homolysis. There are three types of free radicals are present, such as number one is 1 degree free radical. It is also called primary free radical. Second is 2 degree free radical. It is also called secondary free radical. Next is 3 degree free radical. It is also called tertiary free radical. This is the general representation of 1 degree free radical. This is the general representation of secondary free radical. This is the general representation of 3 degree free radical. Remember an important point: higher the possibility of odd electron delocalization through resonance, higher will be the stability of free radical. Take an example. Benzylic radical is more stable than methyl radical. This can be clearly explained by the help of resonance effect. If I will think about the resonance structure of methyl radical, in methyl radical there is no resonance. But if I will think about the benzylic radical, then there is possibility of resonance structure. This is your benzylic radical. I can draw the resonance structure of benzyl radical like this. This bond undergoes homolysis, gives a free radical which combine with this free radical to form the double bond here. Now this free radical present upon this carbon atom. I can draw the rigid structure like this. Now this free radical helps for the formation of double bond here like this. Now here one free radical is present. I can draw the another structure like this. Again this free radical helps for the formation of double bond. Here I can draw like this. Next structure can be drawn like this. Now this free radical helps for the formation of double bond here. I can draw like this. Finally, I can draw the last rigid structure of benzyl radical like this. This is the periodic effect of benzyl radical. These are the rigid structure of benzyl radical. This is your said to be benzylic radical. This is your said to be methyl radical. We know that higher the possibility of odd electron delocalization through resonance, higher will be the stability of free radical. In case of methyl radical, the number of possibility of odd electron is 1. Because here only one structure will be possible. But in case of benzyl radical, the number of possibility of odd electron equal to 4. Look at that, this is the first odd electron, this is the second, this is third, this is fourth. We do not consider about this odd electron because this is similar with this structure. So in case of methyl radical, the number of possibility of odd electron is 1, but in case of benzylic radical, the number of possibility of odd electron is 4. From this data, it is clear that in case of benzylic radical, the number of possibility of odd electron is more as compared to the number of possibility of odd electron in methyl radical. That's why benzylic radical is more stable than methyl radical. Remember, another important point, more is the number of hyperconjugated structure of a radical, more is the stability of the radical. Take an example, isopropyl radical is more stable than ethyl radical. Isopropyl radical is more stable than ethyl radical. The structure of isopropyl radical is drawn like this. This is the structure of isopropyl radical. This is the structure of ethyl radical. Look at that. In case of ethyl radical, there are 3 alpha hydrogen are present with respect to this free radical. Because with respect to this free radical, this is said to be alpha carbon, and this alpha carbon having 3 hydrogen, that hydrogen are said to be alpha hydrogen. So in this case, 3 hyperconjugated structure will be possible. I can draw the hyperconjugated structure like this. Form a double bond here and form free radical here. The structure will be written like this: H bond C bond H, double bond C bond H bond H. Here H dot is present. Suppose here homolysis will be possible, then what will happen? Here one free radical radical combine with this free radical to form the double bond here, and here hydrogen radical will be formed. So I can draw the other hyperconnected structure like this: H bond C bond H, double bond C bond H bond H. Here H dot is present. Suppose here homolysis takes place. As a result, this radical will combine with this radical, and another radical will be formed, that is said to be hydrogen radical. I can draw the another hyperconnected structure like this: H dot C bond H bond H, double bond C bond H bond H. This is the first hyperconnected structure, this is the second hyperconnected structure, this is the third hyperconnected structure. If I will think about the isopropyl radical, in case of isopropyl radical with respect to this carbon radical, there are 6 alpha hydrogen are possible, because with respect to this free radical, this is said to be alpha carbon, this is also said to be alpha carbon. This alpha carbon carry 3 alpha hydrogen, this alpha hydrogen also carry 3 alpha hydrogen. Totally there are 6 alpha hydrogen possible in isopropyl radical. Due to the presence of 6 alpha hydrogen, in case of isopropyl radical there are 6 hyper conjugative structures are possible. In case of ethyl radical, there are 3 hyperconjugated structures. On the other hand, in case of isopropyl radical, there are 6 hyperconjugated structures are possible. From this data, it is clear that the number of hyperconjugated structure of isopropyl radical is more than the number of hyperconjugated structure of ethyl radical. So isopropyl radical is more stable than ethyl radical, because we know that more is the hyperconjugated structure, more is the stability. Next I will explain about the nucleophile. The word nucleophile generally deals with the 2 words. One is your nucleo, another is your phile. Nucleo means nucleus, phile means loving. That means nucleophile means nucleus, loving. An ion or molecule which can donate a pair of electron is called nucleophile. The nucleophile having high affinity towards the positive charge. We know that nucleus having positive charge, so here I can write also nucleophile have higher affinity towards the positive charge, or nucleus. Positive charge species are generally electron deficient species. So here I can write nucleophile have higher electron affinity towards positive charge, or nucleus, or electron deficient center. Remember an important point: nucleophile are electron rich species. There are 2 types of nucleophile, such as number 1 is your negative charged nucleophile. Second is neutral nucleophile. Remember an important point: generally nucleophile are electron rich species. Then a question will arise: how can you know which species are electron rich species? and which species are electron deficient species. You can clearly identify whether an species is electron rich species or deficient species by knowing some tricks. If a species having lone pair, then that type of species are generally electron rich species, and that type of species generally shows the nucleophilic behavior and they are called nucleophile. On the other hand, if a species having negative charge, then that type of species are electron rich species, and that species are also called nucleophile. So there are two types of nucleophile. One is a negative charge nucleophile, another is a neutral nucleophile. That means all the negative charged species are said to be negative charged nucleophile. The examples are OH minus, SS minus, Cn minus, X minus, NH2 minus, RO minus, etc. On the other hand, the molecules which having lone pair, they are also called nucleophile. They generally belong to neutral nucleophiles. The examples of neutral nucleophiles are H2O. Here lone pair is present over the oxygen atom. Similarly, the other examples are H2S, NH3, ROH, RS, H, etc. are the examples of neutral nucleophile. Next, I will explain about the electrophile. The word electrophile generally deals with the two words. One is electro, another is phile. Electro means electron, phile means loving. That means the electrophiles are electron loving. An ion or molecule which can accept a pair of electron is called electrophile. That means a electrophile can accept a pair of electrons from other species. Electrophiles having higher affinity towards the negative charge or electron rich center. Electrophiles are electron deficient species. Generally, there are two types of electrophile. One is your positively charged electrophile. Second is neutral electrophile. All the positive charged species are generally included in the example of positively charged electrophile. The examples of positively charged electrophiles are NO+, NO2+, C6H5, N2+, H+, Br+, Cl+, etc. are the examples of positively charged electrophile. On the other hand, in case of neutral electrophile, the central atom is having less than 8 electrons or capable of accepting a pair of electrons. The examples of neutral electrophile are FeCl3, BCl3, LCl3, SO2, R, CuCl, etc. are the examples of neutral electrophile. If I will think about the BCl3 molecule, look at that. This is the structure of BCl3 molecule. Here boron atom do not have 8 electron. Boron having 6 electron like this. do not satisfy the octet rule. It has 6 electrons like this. So in BCl3 the central atom boron having less than 8 electron, so it have a tendency to accept a pair of electron from other species. That's why BCl3 is said to be neutral nucleophile. It has more tendency towards the electrons like BCl3. These are the also examples of neutral electrophile. Next I will explain about the reaction intermediate. There are different types of reaction intermediates such as number 1 is your carbocation, number 2 is carboanion, next is free radical, next is carbene. At first I will discuss about the carbocation. This is the representation of carbocation. Look at that. Here 6 electrons are present like this. Here the carbocation contains the positive charge carbon. So we can define the definition of carbocation like this. It is defined as a group of atoms which contain positive charged carbon atom having only 6 electrons in its valence shell. There are different types of carbocation such as number 1 is your primary carbocation. It is also called 1 degree carbocation. The second is secondary carbocation. It is also called 2 degree carbocation. The third is tertiary carbocation. It is also called 3 degree carbocation. Already I discussed about the stability of carbocation in inductive phase. Next I will discuss about the structure of carbocation. This is the structure of a carbocation. Here plus charge is present. Here the angle is 120 degree. The hybridization is sp2 hybridization. The structure of carbocation is trigonal planar. This is your empty on hybrid orbital. Next I will discuss about the carboanion. This is the representation of carboanion. Here 8 electrons are present like this. There are 4 electrons present in the valence shell of the carbon atom. Since your negative charge is present over the carbon, so this carbon accepts an extra electron from the other species. So there are 5 electrons present in the valence shell of carbon atom like this. This is the first, second, third, fourth, fifth electrons present in the valence shell of this carbon atom. These 3 electrons are shared by the other atom for the formation of 3 single bond. So there are 8 electrons present in the valence shell of carbon atom in carboanion. So I can define the definition of carboanion like this. It is defined as a group of atoms which contain negative charged carbon atom having 8 electrons in its valence species cell. There are generally three types of carboanion. Such as number one is primary carboanion. It is also called 1 degree carboanion. Second is secondary carboanion. It is also called 2 degree carboanion. Third is tertiary carboanion. It is also called 3 degree carboanion. We already discussed about the stability of different carboanion in the application of inductive effect. Now I will discuss about the structure of carboanion. The geometry of carboanion is drawn like this. Your negative charge will be present. This is your said to be sp3 hybridized orbital. Here the angle is 107 degree. The geometry of carboanion is distorted tetrahedral. The shape of carboanion is pyramidal. Next is your free radical. This is already discussed in the components of the organic reaction. Here I will discuss about the structure of free radical. The structure of free radical is drawn like this. This is your unpaired electron contained on hybridized orbital. The hybridization is sp2. The structure of free radical is trigonal planar. Next I will explain about the types of organic reaction. There are different types of organic reaction. Generally we give importance upon three organic reaction. Number one is your substitution reaction. Number two is your addition reaction. Number three is elimination reaction. At first I will discuss about the substitution reaction. Substitution reaction again classified into three types. Number one is free radical substitution reaction. Number two is nucleophilic substitution reaction. Number three is electrophilic substitution reaction. At first I will discuss about the free radical substitution reaction. Suppose take an example of free radical substitution reaction. CH4 plus Cl2 gives CH3Cl plus Cl. When chlorine is subjected to heating in the presence of sunlight, then chlorine free radical is formed. This chlorine free radical substituted the hydrogen atom present in the methane molecule to form methyl chloride. Since in this reaction a free radical substituted the other part of a substrate, so this type of substitution reaction is called free radical substitution reaction. I can define the definition of free radical substitution reaction like this. The substitution reaction in which a free radical may replace a part of the substrate giving product is called free radical substitution reaction. Next I will explain about the nucleophilic substitution reaction. Take an example of nucleophilic substitution reaction. CH3Cl plus aqueous KOH gives CH3OH plus KCl. Look at that here. KOH gives K plus OH minus ion. OH minus ion here act as a nucleophile. This OH minus ion substituted the chlorine atom present in the methyl chloride molecule to form methyl alcohol. Since in this substitution reaction a nucleophile play an important role, so this type of reaction is said to be nucleophilic substitution reaction. I can define the definition of nucleophilic substitution reaction like this. The substitution reaction in which a nucleophile may replace a part of the substrate giving product is called nucleophilic substitution reaction. Next I will explain about the electrophilic substitution reaction. Take an example. This is the structure of benzene. When it is subjected to reaction with the chlorine in the presence of FeCl3, then chlorobenzene is formed. Also here one byproduct is formed. The byproduct is HCl. In this reaction, the electrophile Cl plus play an important role. So this type of substitution reaction is called electrophilic substitution reaction. Next I will explain about the addition reaction. What is the addition reaction? The reaction in which a small molecule is added to the unsaturated compound to form a single product are called addition reaction. Addition reactions are classified into three types. Number one is free radical addition reaction. Number two is nucleophilic addition reaction. Number three is electrophilic addition reaction. Take an examples of free radical addition reaction. CH3 bond CH double bond CH2 react with the HBr in the presence of organic peroxide gives CH3 bond CH bond Br bond CH2 bond H. In this reaction a free radical play an important role. So this type of reaction are said to be free radical addition reaction. In this reaction at first the free radical added with this compound. Next I will explain about the nucleophilic addition reaction. Take an example. CH3 bond C double bond O bond H react with the HCN gives CH3 bond C bond OH bond Cn bond H. Here HCN and undergoes dissociation gives H plus Cn minus ion. Here Cn minus ion is an example of nucleophile. This nucleophile first added with this organic compound. So this is an example of nucleophilic addition reaction. Here a nucleophile play an important role during addition reaction. So this type of reaction is called nucleophilic addition reaction. Next I will explain about the electrophilic addition reaction. Suppose take an example. CH2 double bond CH2 plus bromine molecule gives CH2 Br bond CH2 bond Br. In this reaction, the electrophile Br plus play an important role. So this type of reaction is called electrophilic addition reaction. In this reaction, the electrophile Br plus added first with this organic compound to form this organic compound. Next I will explain about the elimination reaction. What is the elimination reaction? The reaction in which a small molecule is removed from adjacent carbon atoms, resulting in the formation of additional bond between atoms, are called elimination reaction. Generally there are three types of elimination reaction. One is your alpha elimination reaction, second is beta elimination reaction, third is gamma elimination reaction. At first I will discuss about the alpha elimination reaction. In this reaction, two atoms or groups are removed from alpha position, giving a new stable product. Take an example of alpha elimination. R1 bond C bond R2 bond Cl bond H. Undergoes reaction. At first it loses one H plus ion from the alpha carbon and gives this unstable product. Again this unstable product loses one Cl minus ion and able to form this product. This is said to be one type of carbene. In this reaction, both H plus and Cl minus ion are removed from this carbon atom. This is an example of alpha elimination. Next I will discuss about the beta elimination. In this reaction, two atoms or groups are removed from alpha and beta position. Take an example. When ethyl bromide is subjected to reaction with the alcoholic KOH, then it gives ethene and KBr and water. In this reaction, at first HBr is removed from this molecule, bromine removed from this carbon, and hydrogen removed from this carbon. These two carbons are said to be alpha and beta carbon. Suppose this is your alpha carbon, then this is said to be your beta carbon. And this HBr react with the KOH, gives the KBr and water. Finally, when ethyl bromide subjected to reaction with the alcoholic base, then ethene and KBr and water are formed. In this reaction, two atoms, that is one is your bromine, another is your hydrogen, removed from the alpha and beta carbon respectively. So this type of reaction is said to be beta elimination reaction. Next I will explain about the gamma elimination. In this reaction, two atoms or groups are removed from alpha and gamma position. Take an example, CH2Br bond CH2 bond CH2 bond Br. When this reactant subjected to reaction with the zinc dust, then what will happen? This cyclic organic compound is formed. Here one byproduct is formed, that is your ZnBr2. Suppose this is your alpha carbon, then this is said to be beta carbon, then this carbon is said to be gamma carbon. Look at that, in this reaction, one bromine atom removed from the alpha carbon and another bromine atom removed from the gamma carbon atom. So this type of reaction is called gamma elimination reaction. This is all about the basic concept of organic chemistry chapter. Thank you.